Okay, so we'll look at some integrating trig now. Some of these are a wee bit like the exponentials and the logs and the function of a function, where it's like by inspection. And some of it we need to use formula book for, and then some of it we need to use the double angle formula for it. Okay, so remember, integration and differentiation are the opposites of each other. So if when we differentiate cos, we get minus sine, then when we integrate sine, we get minus cos plus your c. So if we differentiate cos here, we will get minus sine, and the two minuses would make a plus. When we differentiate cos, we get, when we differentiate sine, we get cos. So when we integrate cos, we get sine x plus c. Right, so now sine 5x, so you think, right, well, it has to be something to do with cos 5x. But if we differentiated that, we would get sine minus 5 sine x times 5. So we don't want the minus and we don't want the 5. So that has to be minus a fifth cos 5x, and then your plus c. X squared cos of x cubed minus 2. Well, you know it has to be something to do with sine of x cubed minus 2. So if we differentiate this sine of x cubed minus 2, we would get cos x cubed minus 2 times the differential of the bracket, which would give us 3x squared. We don't want 3x squared, we just want x squared. So times that by a third, and then remember your plus c. Number 5 then, cos x sine squared x, we're integrating. Sometimes people find it easier to write this as sine x all squared instead of sine squared x. And this is one of the questions, the function of a function, where like you've got your brackets. So what we do there is we put the bracket up a power. So we'll get sine x cubed. When we differentiate, we'd get 3 sine x squared, then differentiate the sine x, we will get cos x. So that's nearly what we'll have over here, but we don't want the 3. So we'll have to times that by a third, which means we'll have to times our guess by a third. So our answer is a third sine cubed x, and then remember our plus c. Number 6 then, integrate cos 2x plus 3. Well, we know it's going to be something to do with sine of 2x plus 3. If you differentiate sine of 2x plus 3, you would get cos of 2x plus 3 times 2. We don't want to have times 2, so we're going to have to put a half in. And then remember your plus c. Number 7 then, integrate sec squared 3x with respect to x. So this is where it's useful to have your formula book in front of you and look at actually not the integration page, but the differentiation page. So you'll say, well, what do I have to differentiate to get sec squared? Well, it's actually tan. So let's take your guess as tan 3x. So if we differentiate that, we would get sec squared 3x times 3. But we don't want that 3, so we're going to have to multiply by a third to get rid of it. So we'll have to multiply our guess by a third. So this is a third tan 3x, and then remember your plus c. Number 8, we're integrating cos x over 3 plus 2 sine x with respect to x. So if a fraction here, there's no bracket with a power on it, so we're going to assume it's something to do with logs. So in that case, our guess is the log of the bottom. So when we differentiate that, we would get 1 over 3 plus 2 sine x, and then we'll differentiate what's in the bracket there. 3, when you differentiate it, goes to 0, and 2 sine x then will give you 2 cos x whenever we differentiate it. So we've nearly got what we want, we just don't want this 2. So times by a half, which means we'll have to multiply our guess by a half. So it's actually a half ln of 3 plus 2 sine x plus c. Number 9, then we're integrating sec 2x tan 2x with respect to x. So again, you have to think, well, what can I differentiate to get sec tan? Well, if we differentiate sec 2x, and again, this is where your formula booklet comes in handy, we would get sec 2x tan 2x times 2. So we don't want this 2, so I'm going to multiply that by a half, which means I have to multiply our guess by a half. So our answer would actually be a half sec 2x plus. Number 10 then, we're integrating cosec squared 2x with respect to x. So again, you have to think, well, what could I differentiate that would get me cosec squared? And when you differentiate cot, you get cosec squared. So our guess is going to be cot 2x. When we differentiate that, we get minus cosec squared 2x, then times differential of 2x is 2. So we've nearly got what we want. We don't want the minus and we don't want the 2, so we'll have to multiply by minus a half to get rid of that. So we're going to have to multiply our guess by minus a half. So that means our answer is minus a half cot 2x plus c. Number 11 then, we're integrating cosec 5x cot 5x with respect to x. So again, you say, well, what would I differentiate to get cosec cot? Well, you differentiate cosec to get cosec cot. So let's make our guess cosec 5x. So when we differentiate, you get minus cosec 5x cot 5x, and then we'll have to differentiate the 5x, so times 5. Again, we want to get rid of the minus and we want to get rid of the 5. So I'm going to multiply by minus a fifth, which means I have to multiply my guess by minus a fifth. So our answer is minus a fifth cosec 5x, and obviously plus c. Okay, number 12, we're integrating 6 sine x cos squared x. So again, sometimes people find it useful to write the cos squared x as cos x all squared. So then they can see the bracket with the power on it, so it gives them a better idea of the guess. So y equals cos x cubed would be our guess. To differentiate that, we get 3 times cos x squared, and then we'll have to differentiate cos x, and we'll get minus sine x. That would be minus 3 sine x cos squared x. So we need to get rid of the minus, and we want a 6 instead of the 3, so we're going to multiply by minus 2. So I'm going to multiply my guess by minus 2. So our answer is minus 2 cos cubed x, and then plus c. Number 13 now, we're going to integrate 3 cos 2x sine cubed 2x. Again, if you would prefer to write it out with the sine 2x all cubed, that's fine. So our guess then is going to be sine 2x to the power 4. So we're going to differentiate that and get 4 sine 2x cubed, and then differentiate what's in the bracket. So differentiate sine 2x, we get cos 2x times 2. So we get 8 cos 2x sine cubed 2x. But we want 3, so we need to get rid of the 8 and get a 3 in place. So we'll multiply it by 3 over 8, which means I have to multiply the guess by 3 over 8. So our answer is 3/8 sine to the 4 of 2x plus c. Okay, so number 14 then. So we're integrating sine squared x dx. So it's similar to the last ones where it's got a squared, and we'll go on to do ones with cubes and all the rest. But we can't do this as y equals sine x cubed, because what happens then whenever we differentiate that, it's starting to look okay, but then we'll have to differentiate this sine x and we're going to get cos. So that won't work for us. Okay, so we have to use the double angle formula for this. So we're going to use the cos double angle formula. So cos 2x, you know, it's got 3 ways of writing it. Cos squared x minus sine squared x, 1 minus 2 sine squared x, or we could have 2 cos squared x minus 1. So we want the one with sine squared in it because that's the one that we're using. So 1 minus 2 sine squared x. So if we rearrange this, 2 sine squared x equals 1 minus cos 2x. Divide across by 2. So we get sine squared x equals a half minus a half cos 2x. So we can change this sine squared x to a half minus a half cos 2x dx. Now we can integrate easily. So integrate a half, we get a half x. Integrate cos, we know that it's going to be something to do with sine 2x. So if we differentiate sine 2x, we get 2 cos 2x, but we want minus a half. So we'll have to multiply that by minus a quarter to get rid of the 2 and make it into a minus a half. And remember, our plus c. Question 15 then. I'm going to apologize in advance for this question. It's a horrible one. So if we have cos to the power 4 of x, so we can write that as cos squared x all squared. That's the first thing we do. And then we use the double angle formula like we did in 15, only this time we're using the one that has the cos squared in instead of sine squared. So cos 2x is 2 cos squared x minus 1. So cos 2x plus 1 is 2 cos squared x. So we can write cos squared x as a half cos 2x plus a half. So I'm going to replace the cos squared x inside the bracket with this. So it's a half cos 2x plus a half. Now this whole thing is squared, so it's times a half cos 2x plus a half. Now we're going to multiply out those brackets and we would get a quarter cos squared 2x plus a quarter cos 2x plus another quarter cos 2x, so that's a half cos 2x plus a half times a half gives us a quarter. Okay, so we're getting there. We've got rid of the squared in this term here, but we still have it over here. So we'll have to basically apply the same thing again. So this time though, we're going to have to use cos 4x, okay, because notice when we had an x here, it was 2x over here. We now have a 2x here, so it's cos 4x. So it's the same thing, only instead of 2x and cos squared x, it's cos squared 2x minus 1. So cos 4x plus 1 equals 2 cos squared 2x. Divide by 2. And we get a half cos 4x plus a half. So now we're going to substitute that in over here. And we haven't even got to integrating yet now. So that's a quarter upon a half cos 4x plus a half. And then the rest of it stays the same. I'm going to multiply out the bracket then. So an 8th cos 4x plus an 8th plus a half cos 2x plus a quarter. Now you can tidy it up with the 8th and the quarter. So actually what we're integrating is an 8th cos 4x plus a half cos 2x. So our quarter and our 8th, add them together, we get 3/8. And now we can integrate. So this is going to be something to do with sine 4x. If we differentiate sine 4x, we get cos 4x times 4. We want it to be times an 8th, so we'll have to multiply that by 1 over 32. For the next term, it's going to be something to do with sine 2x. Whenever we differentiate sine 2x, we get 2 cos 2x, but we want a half. So that has to be a quarter in front of it. And then the 3/8 is the easy bit. 3/8 x plus c. Number 16 then, sine cubed x. So notice the last two that we did were sine squared cos to the power 4. They were all even powers of sine and cos. Now these are odd powers. So these are much easier. We're going to separate that up and say, well, that's the same as sine x times sine squared x. Then we know, you've known for many years now, that sine squared plus cos squared is 1. So we can write that as 1 minus cos squared x. Multiply out our bracket. And then take each term in turn. So sine x, when we integrate that, we get minus cos x. Now this one here is one of the ones where your guess is in the bracket. So our guess is going to be 1 more than cos squared. So cos x cubed. So when we differentiate, we get 3 times cos x squared. Then differentiate cos, we'll get minus sine. That's minus 3 sine x cos squared x. So we want to get rid of that 3. So times by a third. So I'm going to have to times my guess by a third. So that's a third cos cubed x. And then remember your plus c. And last one then, number 17, we're integrating cos cubed. So again, it's an odd power. So cos x upon cos squared x. Then we can change the cos squared into 1 minus sine squared. And then multiply out the bracket. Okay, so integrate cos, we get sine. Our second term then, our guess is going to be 1 more than sine squared, so sine cubed. When we differentiate that, we would get 3 sine x squared. Differentiate sine, we get cos. So we want a minus, and we want to get rid of that 3. So I'm going to have to multiply by minus a third. So I'm going to have to multiply my guess by minus a third. So it's minus a third sine cubed x and your plus